So, hello everyone. I'm Dr. D. Suresh, working as assistant professor in the Department of Automobile Engineering, VNR VJET. So, my content for this particular video is green hydrogen. So, as we know, the green hydrogen is one of the trending aspect in the near future because of its so many advantages, and it's basically a kind of a renewable kind of fuel in the future. So this green hydrogen, why basically introduced, are going to be introduced, or maybe going to be a buzzword in the near future, and what it makes, what kind of present scenario makes it to have this attractive fuel in the future. So those things we will cover in this uh, particular lecture. So that's why I gave the topic name is Introduction to Green Hydrogen. So as we know, this hydrogen here and there, those who are working in the area, or maybe those who are having some kind of knowledge about the mechanical engineering, or maybe those who are looking for chemical engineering, they have an idea about this hydrogen terminology. So the green hydrogen, why they added that particular term, and another details, we are going to see what makes we are going for green hydrogen in this particular uh, recorded video. It is introduction to green hydrogen. Before that, just I would like to give some statistics related to the current status of different things which are available across the globe uh, to motivate or maybe to move towards the green hydrogen technology. So in that context, the first thing which I would like to go is the status of carbon dioxide emissions. As we know, this carbon dioxide is basically a greenhouse gas emission. So this particular statistics which I taken from the World Energy Outlook, whatever I am presenting here. So this outlook is the World Energy Outlook. They provided the statistics in last year in 2024. So as per their regards, the carbon dioxide emissions which are going to be present at what level, and in the future at what level, they clearly mentioned in terms of carbon dioxide emissions. So that is greenhouse gas emission. Basically, if you look into this particular picture, so at present the world is emitting around 38 gigawatts, sorry, um, gigatons of CO2, gigatons of CO2. So basically here the terminology which I would like to mention is the steps and APS and NGE. Here it is there, what is meant by steps and what is meant by APS and NGE. This is nothing but, steps is nothing but stated policy scenario. That means across the world there are different policies are framed according to their country norms, or maybe they made some policies to reduce this carbon dioxide emission, greenhouse gas emission. And second one, APS, is nothing but actual uh, policies are promised. So what kind of policies they promised across the globe, this is policies framed within the country, and this is the policies framed across the global platforms across different scenarios by the different governments. And third one is the net zero emission policy. So if you are working for net zero emission policy, or maybe if you are working for stated energy policies, if you are working for actual promised policies, if you are able to do your work, your government is working in that direction, so what kind of emissions will be there, CO2 emissions in 2050, that is indicated on the top of this picture. And similarly on the downside, there is a temperature rise for every year, 0.52 on y, so it is 3 degrees degree temperatures. So every year the temperature rise of the earth will be 0 degrees to 0.5 degrees to 3 degrees. So If the carbon dioxide emissions are increases, this global house gas emissions are increases, then the temperature rise of the earth is increases for 0.5, 1 degree, 1.5. So that will cause a hardward effects on the climatic changes. So in following that, if you see at the stated energy policies level, so at present in 2023 we are generating around 38 gigatons of CO2 emissions. And if you follow same way of the stated policies, in 2030 we can able to reduce to 36 gigatons of CO2. By 2040 it's around 31. By 2050 it is around 29. So we are able to reduce only 9 gigatons of CO2 if you are following same kind of energy utilizations, or maybe same kind of emissions which are continued. If you do that, we are able to reduce only 9 gigatons of CO2. But if you promised policies, if you follow the promised policies, 38 is at current level, 32 at 2030, and 2040 it is 19, and in 2050 it is 12 gigawatts. There is a drastic reduction in the global house gas emissions. Similarly, if it follows the net zero emission policies, if it is implemented across the globe, all the countries, it reduces it to only 6 gigatons in 2050, and in 2040, and 0 gigatons of CO2 by 2050. So that you can try to understand from this world energy outlook. What they presented is here, if the government should work in such a direction that net zero emission, otherwise it's very difficult to provide a beautiful globe to our next generations. That's why they quoted the statements here, emissions are said to peak soon here. That means they will reach highest level, but they will decline rapidly if you follow these policies effectively. How consumer choices and government policies play out will have huge consequences for energy markets and for our planet. So if your planet should be sustained for another few generations, we must and should shift towards the policies which can able to reduce the greenhouse gas emissions. Otherwise it's very difficult. In order to make those policies, it's basically on how the government will look after the energy policies, how the government will look after the consumer choices. Everything should is depends our future planet. Similarly, if you see, the geopolitical risk are said to remain high, but underlying the market balances for many fuels and technologies are easing and signaling shift towards buyer's market. So, for example, um, as the majority of the countries right now are importing the crude oil, because the crude oil is limited to a particular zone of the country. Right now the India situation is that it is in between the Russia and America. When they play political game, the India is suffering to meet the objectives that is importing. So at this junction, these political risks will be, these energy geopolitical risk will always will be present, and it becomes high in the future. So in that particular context, it is better every country should have an energy security option. So that energy security option will comes when you do not depend on a single option. That's why for many fields, if you are going for developing the technologies, or maybe balancing or introducing so many fields, or maybe so many options, if you create it, obviously the energy security will comes into the picture. So that's why there is a scope for, in this context, there is a scope for introduction of new fuels. When you introduce the new fuels, then new technology will come. New technology will come means new infrastructure will come. So that leads to again a good market for those fuels and countries development, and a clean environment. So that's why this particular scenario, in this particular scenario, all the governments will look for a different kind of energy sources, or maybe energy options. So before going to the details of the green hydrogen, just we have a look of the different kind of energy sources which are available across the globe. Those sources will be, these energy sources will be classified into three categories. So for example, the energy sources will be divided into three different categories, that is primary energy and secondary energy, commercial energies and non-commercial energies, and renewable energy, non-renewable energy sources. So why we are looking for these energy sources, as I mentioned, if a country is economically developed or not is basically depends on how much energy it consumes, how much energy it needs, how much energy it has a demand. So if the country developing strategy or maybe the growth parameter at present is the energy demand, so in this particular context the energy will be comes from the different sources. So the sources will be a positive impact on the climate. So if the positive impact is not there, if it is generating more and more this global house gas emissions like uh, CO2 is more, then the country will suffer like anything in terms of human health and climatic changes, adverse environment conditions. So that the government will look after the energy sources which are uh, gives a ever increasing may nullify this ever increasing pollutants. So that's why they will introduce a new fuels, so that new energy sources or maybe new technologies that may reduce the emissions as well as they meet the demands. So whatever the energy source they introduce, they should meet the demand, and at the same time they can reduce the global global house emissions which can harm for the human beings as well as the climates. So that's why this energy sources basically which we are classified into primary and secondary, commercial and non-commercial, renewable and non-renewable energy. So just if you look into this primary energy sources, these basically stored or maybe the energy sources generally available in the earth or maybe in the nature. So those are exist in the nature, so those we will extract it and we will use it for our energy generation in different purposes. So the common examples which I quoted here is the coal is directly available, oil that is crude oil, natural gas, biomass that is your wood, whatever the wood we are seeing at present in which is present in our nature, those are called primary energy sources. Apart from that we have another sources which may damage very high to the atmosphere, those will be the nuclear energy from radioactive substances. These are also available in the earth, but the thing is here they may cause a lot of damage to the climatic condition and ecosystem also. If you see the thermal energy stored in the earth interior, if you try to extract it, there is a ecosystem imbalance. That's why so we are primarily depend on the sources in case in the category of primary energy sources, basically coal, oil and natural gas. In olden days we are heavily dependent on the biomass, that is wood. Slightly after the generation will changes from um, one generation to another generation, we shift towards the coal, and after that we shift towards the oil and natural gas. So right now we are heavily dependent on these three fuels, especially coal, oil and natural gas. The world is running because of these three fuels energy sources only. So otherwise the entire world economy will be fall down if these systems, if any imbalance will comes in terms of energy sources of these coal, oil and natural gas. And if you look further, so if this primary energy sources basically used for different purposes. So as I mentioned, these are the energy sources. So once these energy sources we will process for some other usages for our day to day life, either industrialization, transportation, any other category, whatever, building construction or maybe any other. So the primary intention of these extraction of these energy sources is here. So in origin form those will be available in terms of source, either coal or maybe nuclear or maybe natural gas or maybe petroleum, that is in terms of crude oil. So the extraction which is maybe available through the deep mines, oil wells like petroleum, gas wells for the natural gas, and nuclear by using the mining technology. So and hydro is also there, but this hydro is limited percentage at present when the seasonal base this is. So when you do some kind of extraction, then we will do some kind of processing. Different kind of processing technologies are available. The final objective of this is Either if it is in a coal, the coal is used for either generation of energy, steam, or maybe thermal applications, or maybe generation of electricity. Similarly, the natural gas we can directly use in the transportation sector, or maybe we will use for generation of power. And similarly, the oil which is generated, the crude oil, we are making some kind of processing, and we will also generate some kind of different fuels like LPG, petrol, gasoline, diesel, or any other thing. So many chemical products will come, so those will be used. Some will be used for generation of electricity in industries, or maybe some will be used for transportation sector. So the prime importance here, the energy sources, is generation of electricity. This electricity is right now is option in every kind of application of, or maybe comes into a very important note of the human's life, either for industrialization, or maybe globalization, or maybe industrialization, or maybe any kind of luxury life of the humans. So all these things will be depends on the electricity. So if there is no electricity, then it's very difficult to imagine the world. So further, the major source will be here the primary energy sources like coal, oil, natural gas. So here the problem we will is, as I mentioned, the generation of the carbon dioxide emissions, global house gas emissions. That makes to shift towards another kind of energy sources. And if you see the thing, if you primary energy sources, either we can use directly coal, oil, or gas, we can able to use directly or converted into steam or electricity. So the primary energy sources mostly converted into industrial utilities into a secondary energy sources. For example, coal, oil, gas are converted into steam or electricity. The steam or electricity we will use it in the industrial purposes, not as a direct. Coal we will not use directly, gas we will not use directly, or oil we will not use directly. They may converted into a some other form, that is steam or electricity, that we will use in different sectors. Similarly, we can use directly in some other sources like biomass, we can use it directly, um, but it's not so much effective in terms of efficiency. If you convert into another form like steam and electricity, they may give some kind of more efficiency point. And similarly, commercial energies and non-commercial energies, if you energy source, we can call it as, when we will call it as uh, a commercial energy, when it is available in the market with a particular price, it's a definite price, then we can call it as a commercial energy. Basically we can call it as electricity which is available per unit for household, per unit cost something across the states, across the across the country, and across the different zones of the uh, global. So similarly, coal per kg how much. Similarly, defined petroleum, for example diesel and petrol, or maybe any other thing, we are taking it per liter 100 rupees, per liter 120 rupees, per liter 150 rupees. So we are taking with a definite price. And similarly, the commercial energy forms basis for industrial, agriculture, transport, and commercial development of the modern world. So the energy sources which are available in a commercial in market, those are uh, responsible, or maybe the prime importance of any country for agriculture growth, industrial growth, transport growth, or any other thing. So that's why in this statement also, in the industrialized countries, the commercialized fuels are predominant sources, not only for economic production but also for many household tasks of the general population. So if these primary energy sources, or maybe commercial energy sources, are very prime important for any particular country as per the statement which I mentioned here, so these are integral part of your human life. Those examples which we mentioned, electricity, coal, oil, and natural gas, etc., these we can call it as a primary energy sources as well as the commercial energy sources. Similarly, non-commercial energy sources, which are nothing but those are available for the generation of energy, but those are not available in the market. So those are not available in the commercial market, but we can generate in our households as an individual level, or a small quantity level. For a particular application I can able to generate it. For example, those will be firewood, or maybe cattle dung. and agriculture wastages, municipal wastages. So those will be not comes into commercialized, but we can able to use generation of electricity or some other purposes for heating the water or maybe any other thing. So some other household things we can generate at a small scale and we will use it. They will not able to sell it in the market. Those we can call it as a non-commercial energy sources basically. And third one which comes into category is the renewable energy sources. So the drawbacks which are present in the primary energy sources as well as the secondary energy sources are commercial and non-commercial energy sources will think of the government or different countries across the different countries of the governments. They look towards the another kind of energy sources. Those will be the renewable energy sources. Those renewable energy sources will be having a particular kind of character, that is those are non-exhaustible. Those will be non-exhaustible, those will be available in the nature. So those will be not exhaustible, whereas the primary energy sources will be after some time they may be exhausted from the nature. So those will be not available in the earth. But whereas the renewable energy sources, it's not like that. Until earth exists, those will be present. The first one will be the wind power, similarly solar power and geothermal energy, tidal power, like that. So those will be, we can call it as a renewable energy sources. Those who are getting attracted, or maybe all countries are moving towards this renewable energy power generation. So those contribution at present there will be, at present it's less, but when we mentioned in the first starting of this session also, when we move towards the net zero emissions, or maybe um, as per the promised strategies, when you want to shift or maybe when you want to reduce the global CO2 emissions, there is a necessity towards to go for renewable energy sources. Until and unless it is not possible to go for net zero emissions by 2050. Similarly, the non-renewable energy sources, we can call it as the conventional fossil fuels. Those will be coal, oil, gas. So those will be in the deployed with the time. Those will be in the future. As the time increases, the their consumption will be increases, their availability in the earth will be not increases because the demand will be very high, and their source or the origin will be very less. The quantity which is available on the earth will be less, so that they will be deployed with the time. Those will be not a prime options in the future. At present, those are the prime options for the power generation and energy generation, as well as the prime energy sources at present. But in the future, the renewable energy sources are the prime energy sources across the globe for reduction of global CO2 emission, as well as the beautiful planet in the future. So if you see, look into this, there will be different kind of renewable energy sources like solar, wind, and hydroelectric, biomass, geothermal, and finally is the hydrogen. This I exclusively added here because hydrogen, which is not available on the earth in the direct form, it is available in some other chemical forms, some others, and just we can say that it is not extracted from the earth directly. But when you use the hydrogen, like when you extracted the hydrogen with through a no, less harm to the environment processes, through that process, if we extract it and if we use it properly, then it becomes a renewable energy source. At present, I can say that the hydrogen is not a renewable energy, but in the future it becomes a renewable energy when you use it through a concept called green hydrogen. That means the processing, that means the extraction of hydrogen follows a green channel, the usage of hydrogen follows a green channel, and then it completely call it as a green hydrogen. Simply the production process of hydrogen, if you follows the green channel, we can't call it as a green hydrogen. Similarly, if you follow the distribution channel as a green, then it is not called as a green hydrogen. From tank to wheel, that means when, sorry, well to wheel, that means where it is originated and where it is used, entire thing is, if you are able to make it as a net zero emissions, entire process of the hydrogen usage, if you make it as a net zero emission of CO2, then we can call it as a green hydrogen. Those parts we will see what are the different kinds of hydrogens will be present in coming sessions. So at this junction you can call it as I am declaring that in the future it is the green hydrogen is a renewable fuel. And if you see some of the disadvantages, that means the right now if you want to go for a green hydrogen concept, there are some disadvantages which are available for each and every category. For example, if you say the wind energy, which is very expensive in terms of infrastructure development, that means per unit of generation of electricity we need to invest a lot, and expensive production and noisy turbines and intermittent supply. When the wind will come, then only the electricity will comes into the picture, and it is not able to supply the demand at present. So that's why we kept it in some location. Further, we need to look after this, disturb the local wildlife. Similarly, hydroelectric energy, expensive manufacturing and limited locations. When there is a projects, then only there will be present. Similarly, the tidal energy, when the waves will come, then only the tidal energy will come, and a high investment cost. If the nature will do some kind of imbalance, then there is a loss of this infrastructure also. And the solar energy, which is available a lot, but the kind of the land usage and the kind of infrastructure, the kind of material availability for the solar panels, so those will be giving at present there are high costs which are present. But we are moving toward this solar energy. The government is introduced so many policies at present, so in India, so that the everybody is moving or maybe looking after their household with a solar concept to, instead of depending on thermal electricity, they are depending on the solar electricity at every household. The government is looking at the policies of the government, especially in India, they are moving towards in this direction. But when you look after the another concept, that is hydrogen energy, here after solar, the most possible way we can see for usage in the industries is the hydrogen energy. So the basic disadvantages here: expensive electrolysis process, high energy requirement, greenhouse gas emission, difficulty in transportation, and safety concern. So basically, if you able to follow the traditional extraction process or maybe conventional extraction processes for hydrogen, as well as for hydrogen utilization, if you follow that, they will extract the greenhouse gas emissions still further. So to avoid that, if you follow the green channels, then or maybe green production base and green utilization base, then there is no greenhouse gas emissions. Only thing we need to address in terms of infrastructure requirement for generation of hydrogen and utilization of hydrogen, it may address the issues by 5 years, as the government is introduces the national green hydrogen mission. So by 2030 they would like to generate around approximately around 100 giga tons of an hydrogen. So right now we are at the 5 million tons. So they are able to we were able to get an uh, demand of around 80 million tons. So the government is looking for aggressively moving for the green hydrogen generation across the India, and they are making the policies. As I mentioned, green hydrogen mission, they are allotted around 19,500 crores. So for the to create an environment for the green hydrogen green hydrogen mission. So that is introduced in phase wise. For up to 2026 is one phase, from 2026 to 2030 is another phase. They frame that. So that is also we will discuss in further. So before that, just you can try to see what are the different possibilities as I mentioned. So what makes the government think towards this green hydrogen? As I mentioned, the first one is the greenhouse gas emission due to the usage of this primary energy sources or maybe commercial energy sources or maybe non-renewable energy sources, which makes the government think towards the renewable energy sources. So in renewable energy sources we have a different options, out of which the prime importance we are given at present is the solar as well as the green hydrogen. So before that, you can understand in further this global energy scenario, domination by different kind of renewable energy sources from 1950 to 2050. If you look into that, in 1950 we have the primary energy source is the coal, and the secondary energy source is the primary energy source, which is the dominant or maybe which can occupies major percentage, is the coal. As the years are progressing, in 1975, if you look it in 25 years of span, the crude oil is dominated across different kind of energy sources or maybe energy needed by the uh, globe, across the globe. So the vertical direction, this vertical axis is indicates exajoules. So this much energy is generated, their contribution is around we need around 100 uh, joules of exajoules, out of which the major contributor is the comes from the crude oil. Similarly, it is continuous until 2023. If you see, there is a still the major contributor is the crude oil, second is oil, third is your natural gas, and fourth one is the renewable energy. Still, they are lack a lot. The energy's demand is very high, but they are producing very less through the renewable concept. But when you move towards the 2050, that is net zero emission policies, 90% of energy demand, or maybe around 60% of the energy demand, is supplied by the renewable energy sources. If you follow the net zero emission policies, or if you follow the promised strategies, if you follow the promised strategies across the globe, then at least we can see 50% which will come from the renewable energy sources. Still, if you follow the stated policies, they will replace only 30%. So the thing is, we need to look on only net zero emissions only. Otherwise, it's very difficult to give a better planet to our future. So in this particular context, we need to introduce a different energy options which can drive towards the net zero emissions. So that's why we introduced the global energy scenario things. The last decades we can see there is a global energy mix gradually comes down 82% to the 80%. That is the fossil fuel contribution. They be reduced by 2%. But at the same time, there is a increase of energy 15% over this period. Every year we are increasing around in a 10-year span we increasing around 15% of the energy demand is increased. But at the same time, there is a growth of 40% of growth in the clean energy. So if we work in this direction in the future also, definitely we can reduce this fossil fuel contribution from 80 to 50 and 40 and 30 and below of that also. So in advanced economies, the overall energy demand declined from average by 0.05% per year from that past decade. But whereas the developing countries, the demand will be increases further and further. So that's the basic thing. So similarly, in emerging markets, a grouping includes so almost 85% of the world population. Basically, those are the Asian countries. 85% of the world population energy demand is increased around 2.6% per year. Whereas the developed countries, they are reducing the energy demand 0.5% on an average per year. Whereas the energy demand in emerging economies, there is increase of around 2.6 percentage from the last decade. So that's why you can see there is a rise in the economy and there is a rise in the industrial output always leads to a increased energy demand. So all the developing countries will needs a energy for their needs in the future also. At that time, we need to address the things with a possible clean energy fuel sources. So with the rapid rate of development, the clean energy must work harder to replace the oil, gas and coal in emerging market because they are rising. There is no declinement in the energy demand, so that they will always there is a rise or maybe scope of the more and more utilization of these primary energy sources. With this with the in this competence, the rise of renewable energies will very difficult or maybe very what we can say they are facing very difficult challenge to replace these fuels, and government will also look after about this introduction of these renewable fuels to replace with this fossil fuel utilization in the future. Otherwise, it's very difficult uh, uh, to decrease the CO2 emissions. So basic things further, if you see the sector wise also, the buildings will, if you see the electricity utilization in the buildings is 2023 is very less, but as the 2050, if you see in 2050, the utilization on the y-axis similar to in the previous graph, then exajoules. So in 2050 also the electricity demand will be very high if you follow the stated policies. If you follow the promised strategies, it may decrease further. If you net zero emissions, the electricity demand further it is decreased in the buildings if you follow the clean energy policies. But the thing is, the electricity should be supplied from the clean fuels. Similarly, if you take a transportation sector, so there is a 90% depends on the fossil fuels at present. But in the future, in 2050, as we are moving towards in 2050, there is a replacement. The fossil fuel replacement in 2050, if you follow the net zero emissions, their contribution is very less. But in 2050, still if you follow the stated policy, it contribute around 60 to 70%. But if you say in the future in 2050, if you follow the promised strategy, it may replace only 50%. So we need to move towards aggressively in the transportation sector around net zero emissions. Why we are concentrating on this net zero emissions? Because those are mainly responsible for, even though their contribution towards the energy usage is very less, but their emissions impact is very high. Similarly, in case of an industry sector, the renewables kind of thing, so the electricity demand will be goes down, the renewable fuels and low emissions will comes into the exist in the 2050. Right now their contribution is very less, but in the 2050 they may occupy it. Whatever the electricity we are producing, the usage in 2050, it should be done from the clean fuels, otherwise it's very difficult to give a plan. Why I am repeating this word is that motivates all the governments to think on a sustainable fuel option that's called green hydrogen. Okay, so this is the global energy scenario. Electrification access across the scenarios, all the sectors providing heating, cooling, mobility. So by 2050, the share of electricity of total finance increases by half of the steps, doubles in APS and triples in the energy scenario. Increases by half in the steps in the stated energy policies, doubles in the APS and triples in the NJD scenario. So the electricity demand will be goes and goes. So those will be replaced with the unbattered fossil fuels are 50 replaced by electricity generated by clean energy sources. As the electricity demand will be increases, the portion of electricity, the share of the electricity is increases, we need to shift towards the clean fuels. Just we are shifting from diesel to the gasoline to the electric vehicles at present. So the electric vehicles need an electricity. Similarly, the different option industries at present, they need the electricity, but the electricity is coming from the coal, the primary energy source that we are seeing, or maybe the gas that may be replaced. Otherwise, the consequences will be very high. So that's we are mentioning here. Similarly, direct use of renewables including modern bioenergy, solar, thermal, so those will be share of unbeaten fossil fuels declines from today's level by 30% in steeps, 65% in APS, 95% in NJD scenario that we already mentioned. So if you are able to use this, so and hydrogen based fuel, the share of unbated fossil fuels, if you are continuously increasing these renewables in the future, or maybe hydrogen and hydrogen based fuels, the share of renewable fuels will be goes down in the future. So in hard to abate sectors such as aviation and shipping and biofuels, the fuels replace around 50 exajoules of fossil fuels by 2050 in NJD scenario. So we can't replace this completely, but 50 exajoules is very high. So okay, so similarly the remaining topics we may continue in the next session. At this junction, just we can try to understand some of the things related to the motivation of green hydrogen, motivation of the governments towards the green hydrogen concept. Okay, thank you. See, these topics we may discuss in next session. Thank you. If you have any doubts, please kindly post it in the comment section so that I will address the things further. Thank you.
Like, share, comment, and subscribe. VNR Digital Learning Resource YouTube channel.